Are you preparing for a LoadRunner interview? This video will guide you through the top 25 questions you can expect, along with the answers. This comprehensive guide will greatly enhance your understanding and readiness. Whether you're a newbie or an experienced professional, these questions will serve as an essential resource. By watching this video, you'll be more confident and prepared to ace your LoadRunner interview. 1. What is LoadRunner and its primary purpose? LoadRunner is a software testing tool from Micro Focus. It is used to test applications, measuring system behavior and performance under load. LoadRunner can simulate thousands of users concurrently using application software, recording and later analyzing the performance of key components of the application. LoadRunner simulates user activity by generating messages between application components or by simulating interactions with the user interface such as key presses or mouse movements. The messages and interactions to be generated are stored in scripts. LoadRunner can generate the scripts for you, such as capturing them from existing user activity, or you can custom code them. LoadRunner's primary purpose is to identify and diagnose problems in software applications by testing and analyzing their performance. This powerful tool helps to ensure that applications will run smoothly under their expected load, identifying bottlenecks and determining the cause of performance issues. It's also used to evaluate the scalability of an application as the number of users increases. By simulating the actions of many users accessing the application simultaneously, LoadRunner helps to ensure that the software can handle high traffic and usage levels without compromising functionality or performance. 2. Explain the architecture of LoadRunner. LoadRunner is designed on a distributed architecture model. It mainly consists of three modules: Virtual User Generator, VuGen, Controller, and Analysis. VuGen is where scripts are developed to simulate user actions on the system under test. These scripts are then executed by the controller, which emulates multiple virtual users and applies the load on the system. The performance of the system under different instances of load is captured and saved in results files. The analysis module is used to analyze these results files, generating graphs and reports for detailed performance analysis. The architecture of LoadRunner is based on a distributed model, comprising three primary modules, namely, Virtual User Generator, Controller, and Analysis. The process begins with the Virtual User Generator, where we create scripts that simulate the actions of end users on the application under test. Once these scripts are ready, they are passed on to the controller. The controller takes these scripts and emulates multiple virtual users simultaneously, applying varying degrees of load on the application to test how it performs under different instances of load. The data from this performance testing is then stored by the controller in results files. These files are taken by the analysis module, which processes and interprets the data, generating graphs and reports for a more detailed understanding of the application's performance. This enables testers to identify any performance bottlenecks and take necessary corrective measures. 3. What are the key components of LoadRunner? LoadRunner is composed of three main components. The first is VuGen, or Virtual User Generator, which is used to record and edit scripts that simulate user interactions with the application. The second component is the controller, which manages and controls all the virtual users during the load test. It allows the tester to set the number of virtual users, their behavior, and when they will start and stop. The last component is the analysis, which provides detailed graphs and reports of the performance test results. This component makes it easier to identify performance bottlenecks and issues. 4. Describe the role of the Virtual User Generator, VuGen. The Virtual User Generator, also known as VuGen, plays a crucial role in LoadRunner. It is responsible for creating scripts that simulate real-world user behavior on an application under test. These scripts, once created, are used by the controller and load generators to generate load on the application. VuGen essentially mimics end-user interactions with an application, capturing these interactions as scripts. These scripts are then used to replicate the same behavior by numerous virtual users concurrently during a load test, thus aiding in identifying and addressing performance bottlenecks before the application goes live. VuGen supports a wide variety of protocols, making it flexible enough to work with many different types of applications. It also offers features such as parameterization and correlation to handle dynamic data and maintain session-specific values, respectively. This helps in creating more realistic and accurate load testing scenarios. 5. What is the function of the LoadRunner controller? The LoadRunner controller is a critical component of the LoadRunner software. It plays a pivotal role during performance testing as it is responsible for managing and controlling all the virtual users, Vusers, during the test execution. The controller allows you to create load test scenarios and specify the number of Vusers to generate load on the application under test. It also provides real-time monitoring and analysis of the system's behavior under different load conditions. The controller enables you to gather data regarding the system's response times, throughput rates, and resource utilization levels. This data can then be used to identify any performance bottlenecks or issues within the system. The LoadRunner controller is therefore an essential tool for performance testers, providing them with the ability to accurately simulate real-world load conditions and monitor the system's response. By providing detailed and actionable data, it enables testers to ensure that the software can perform effectively and efficiently under various load conditions. 6. How do load generators work in LoadRunner? Load generators in LoadRunner are components that generate the load against the system under test. They simulate the actions of multiple users and thereby apply the desired load on the application. These generators work by executing scripts that you have created and compiled using the virtual user generator, VuGen. Multiple load generators can be used simultaneously to replicate the actions of a large number of users accessing the system from different geographical locations. The LoadRunner controller manages the distribution of scripts to these generators. Load generators are essentially the backbone of LoadRunner, generating the necessary load on the system being tested. They accomplish this through the execution of scripts, painstakingly created and compiled through the virtual user generator. It's possible to use multiple load generators at once, enabling the simulation of a vast number of users accessing the system from various locations around the world. Their operations are managed by the LoadRunner controller, which oversees the distribution of scripts to the load generators. This system allows for comprehensive and accurate stress testing of a program, ensuring its capability to handle heavy user traffic without significant performance degradation. 7. What types of performance testing can be conducted using LoadRunner? LoadRunner is a versatile testing tool that supports a wide range of performance testing types. These include load testing, stress testing, volume testing, endurance testing, and scalability testing. Load testing. This tests the system's behavior under a specific load, usually the expected concurrent users or transactions for the system. Stress testing. This determines the system's robustness by testing it beyond its designed capacity to identify any potential breakpoints or performance issues. Throughput is a MEA volume testing. This involves testing the system with a large amount of data to check its performance and response times. Endurance testing. This tests the system over a long period of time to check if it can sustain the continuous expected load. Scalability testing. This tests the system's ability to grow and scale, either by increasing the load or changing the software or hardware configuration, without affecting its functionality and performance. Each type of testing serves a unique purpose and helps in identifying different types of performance bottlenecks. By using LoadRunner, testers can ensure that their system is reliable, scalable, and robust against different types of load conditions. 8. Define throughput and its significance in performance testing. Throughput in the context of performance testing is the total number of requests that a system can handle within a specific time frame. It is often measured in requests per second, transactions per second, or similar units. High throughput is indicative of a system's ability to handle heavy loads, thus making it an integral aspect of performance testing. By evaluating throughput, testers can gauge the system's capacity and scalability. If the throughput is low, it might indicate that the system may struggle to handle traffic spikes or increased load in real-world scenarios. Throughput, therefore, optimizing for high throughput is a key goal in performance testing. Throughput is a measure of how many units of information a system can process in a given amount of time. It is crucial in performance testing as it helps in identifying the efficiency of an application under test. It's a key indicator of the system's robustness and reliability under different load conditions. An application with high throughput can process more transactions per second, indicating better performance. Conversely, if an application has low throughput, it indicates that it can handle less load, which may lead to performance issues such as slower response times or even system crashes during peak load. Hence, throughput is a critical factor to be measured during performance testing. 9. What are checkpoints in LoadRunner, and why are they used? Checkpoints in LoadRunner are utilized for verifying the information obtained from the server during a script's execution. It can be compared to the validation points used in manual testing. Checkpoints are crucial for ensuring that a test accurately emulates the user's activity on the system, and for verifying that the system behaves as it is supposed to. They provide a way to confirm that the server's response contains the expected values and that the system performance meets the stipulated requirements. For example, if a user logs into a system, a checkpoint can be used to verify that the login was successful by checking the server's response for a specific value indicative of success. If the server's response does not contain this value, the checkpoint will fail, indicating a potential issue with the system's performance or functionality. This aids in identifying issues at an early stage, thereby reducing the risk of system failure during operation. Checkpoints are also used to measure the time it takes for a server to respond to a request, which can help identify performance bottlenecks. They are an essential tool for ensuring the reliability and performance of a system. 10. Explain the concept of parameterization in LoadRunner scripts. Parameterization is a critical feature of LoadRunner scripts that allows testing to be more effective and realistic. It involves replacing fixed values in the script with parameters, which can then be dynamically generated or selected from a source like a database or file during script execution. This helps to simulate real-world usage more accurately, as it allows each virtual user to use unique data, rather than repeating the same transactions with the same data. This is important for achieving reliable and comprehensive test results, as it helps to uncover issues that might only occur with certain data. For example, in a script simulating user login, rather than having all virtual users log in with the same username and password, parameterization could be used to have each user log in with a different, unique set of credentials. This would not only make the test more realistic, but would also help identify any potential issues that might occur when multiple different users are trying to log in at the same time. 11. What is correlation, and why is it important in LoadRunner? Correlation is a crucial aspect of LoadRunner. During performance testing, certain requests or responses might be unique to each run or user. Correlation handles these dynamic values to ensure accurate and effective testing. It captures the unique data from a server response and uses it for subsequent requests. Without correlation, scripts might fail due to incorrect or duplicate data, leading to flawed test results. Hence, it plays a vital role in maintaining the integrity of performance testing using LoadRunner. In LoadRunner, correlation is typically used in two ways, manually or automatically. The tester can manually correlate by identifying the dynamic values, capturing them, and replacing them in the script. Automatic correlation, on the other hand, allows LoadRunner to automatically identify, capture, and replace dynamic values. Each method has its advantages and is chosen based on the complexity of the test scenario and the convenience of the tester. Correlation ensures that every virtual user emulates the actions of a real-life user as closely as possible, thereby producing accurate and reliable test results. It is, therefore, a fundamental aspect of performance testing with LoadRunner. 12. Differentiate between manual and automatic correlation. Manual correlation involves recognizing dynamic values and replacing them with parameters manually. This process requires a deep understanding of the application and the script. On the other hand, automatic correlation is when the tool automatically recognizes and replaces the dynamic values from the server response. This is typically based on correlation rules defined by the user. Although automatic correlation can save significant time, it might not be as accurate as manual correlation. Manual correlation provides full control and can handle complex scenarios better. The distinction between manual and automatic correlation lies in the level of user involvement and control. Manual correlation requires a keen eye for identifying dynamic values and substituting them with parameters by hand. It demands an in-depth comprehension of both the application under test and the script. In contrast, automatic correlation lets the tool itself identify and replace dynamic values in the server response. This process is guided by correlation rules set by the user beforehand. Even though automatic correlation can be a time saver, its accuracy may not be on par with manual correlation. Manual correlation grants the user complete control, enabling handling of more intricate scenarios effectively. 13. How do you identify performance bottlenecks during testing? The process to identify performance bottlenecks during testing involves several steps. First, you need to establish a baseline for system performance under normal conditions. This includes monitoring and recording key metrics like response time, CPU usage, memory consumption, and network bandwidth. Once you have a baseline, you can then execute your load test and compare the results with the baseline metrics. Any significant deviations can be an indication of a performance bottleneck. To locate the source of the bottleneck, you may need to analyze the system logs, database queries, and application code. Tools such as profilers and monitors can also help pinpoint the exact location of the bottleneck. Remember, the goal is not just to find the bottleneck, but to understand why it's happening and how it can be resolved. Sometimes, the bottleneck may be due to poor coding practices, inefficient database queries, or insufficient hardware resources. Identifying and resolving these bottlenecks can significantly improve the performance and scalability of your application. 14. What are the different types of logs available in LoadRunner? LoadRunner provides various types of logs to aid in script debugging and results analysis. There are two primary log types, replay and extended logs. The replay log records the actions and responses of the Vuser during script execution for debugging purposes. This log helps identify any errors or issues that occurred during replay. The extended logs provide more detailed information, including parameter substitution, data returned by the server, and advanced trace. These logs are useful when you need a deeper understanding of the script's behavior or response from the server. However, it's worth noting that enabling extended logs can consume significant disk space and slow down the execution process. Therefore, it's advised to use them judiciously and only when necessary. Remember, effective use of logs can significantly aid in identifying and resolving issues during the performance testing process. 15. How do you define think time in LoadRunner, and why is it necessary? Think time in LoadRunner is defined as the time that a user waits between interactions with a web application. This could be due to reading content, making decisions, or inputting data. It is an important aspect of realistic load tests as it mimics a real user's behavior. Without implementing think time, the load test would generate false results as it would be sending requests to the server nonstop, which is not how real users behave. For instance, certain server processes may have time to recover in between requests when think time is incorporated, which could potentially mask performance issues that would occur under constant load. Therefore, accurate scripting of think time is essential to creating realistic load test scenarios and obtaining reliable test results. It is necessary to include think time in LoadRunner scripts because it helps to simulate real user behavior more accurately. Not every user is going to be continuously interacting with the application. There will be periods of wait time, and these need to be taken into account when creating performance testing scripts. By doing this, you can ensure that the load testing results accurately reflect how the application would perform under realistic conditions. 16. What is the significance of the analysis component in LoadRunner? The analysis component in LoadRunner plays a crucial role in understanding test results. After a test run, it provides a detailed report, giving insights about the system's performance under different loads. It helps identify bottlenecks and areas for improvement by providing various graphs and reports such as transaction response time, error report, system resource usage, and so on. With this data, developers get a clear picture of system behavior and performance. This information helps them make informed decisions on optimizing system performance and resolving potential issues. The analysis component thus becomes an indispensable tool in performance testing strategy. The analysis component also provides the ability to merge and compare different test result sets, making it easier to track performance trends over time. This aids in assessing the effectiveness of performance tuning efforts and understanding how changes to the system or the environment affect performance. 17. Explain how to create a load test scenario in LoadRunner. Creating a load test scenario in LoadRunner involves several key steps. First, you need to define the performance testing requirements. This includes understanding the application under test, the target load level, and the key transactions to be measured. Once the requirements are defined, you create the virtual user scripts using VuGen. These scripts simulate the actions of real users on the application. You need to parameterize the scripts to add variation to the virtual user behavior and correlate the scripts to handle dynamic data. Next, you design the load test scenario in the LoadRunner controller. You select the scripts to be included in the scenario and define the load pattern. The load pattern determines the number and timing of virtual users running the scripts. Finally, you run the scenario and monitor the application performance. After the test, you analyze the results using the LoadRunner analysis component to identify any performance bottlenecks. 18. What protocols does LoadRunner support for performance testing? LoadRunner can handle an array of protocols for performance testing. It can manage the protocols for web applications, which includes HTTP, HTTPS, and AJAX. For database testing, it supports Oracle, MS SQL, and MySQL. LoadRunner also handles protocols for various technologies such as Java, NET, and SAP for remote services and messaging. It supports protocols like RDP, Citrix, and SOAP. This variety of supported protocols makes LoadRunner a versatile tool for performance testing of diverse applications and systems. For instance, in testing a web application, LoadRunner's support for HTTP and HTTPS protocols becomes crucial. It enables the tester to emulate large numbers of virtual users interacting with the application, thereby assessing its performance under significant load. Similarly, the support for database protocols like Oracle and MS SQL allows testers to evaluate the performance of database-driven applications when multiple users access them simultaneously. In a nutshell, LoadRunner's extensive protocol support enhances its testing capabilities and makes it a go-to tool for performance testing. 19. How do you determine the number of virtual users, Vusers, required for a test? The determination of the number of Vusers needed for a test involves several factors. First, you need to consider the expected load on your system under test, SUT. This can be based on the expected number of concurrent users or transactions per second. Another factor is the type of test you are conducting. For instance, in load testing, you might want to simulate the peak load, while in stress testing, you would want to push the system beyond its capacity. Lastly, consider the hardware and network limitations. It's important that your load generators have enough resources to simulate the desired number of users without becoming a bottleneck themselves. The number of virtual users required for a test can be determined through understanding the system's capacity, the expected load, and the objectives of the test. If the system is expected to handle a certain number of users at peak times, then the test should be designed to simulate this load. Additionally, the nature of the user interaction with the system should be considered. High-traffic websites may require more virtual users, while a system with less user interaction may require fewer. It's also important to factor in any system constraints or limitations when determining the number of users. 20. Describe a situation where endurance testing uncovered a critical issue using LoadRunner. In a recent project, we utilized LoadRunner for endurance testing of a web application. We executed a test scenario that involved a continuous load over a period of 24 hours. The aim was to identify potential memory leaks, response time degradation, or other system issues that might occur over extended periods of operation. Further investigation revealed a memory leak issue in the application's backend. The leak was not immediately apparent during functional or short-term performance testing, but became evident during endurance testing. This incident underlines the criticality of endurance testing in uncovering issues that only manifest over long periods of system operation. By using LoadRunner, we were able to identify and rectify the problem before the system went live, preventing potential downtime and negative user experience. 21. What are some common performance metrics monitored during a test? Performance metrics provide quantifiable data about the system's performance under different workloads. These metrics play a crucial role in understanding the system's behavior, enabling testers to identify performance bottlenecks and optimize the system accordingly. During a performance test, some of the commonly monitored performance metrics include response time. This measures the time taken by the system to respond to a request. It consists of network latency, server processing time, and data rendering time. Throughput. This measures the number of transactions processed by the system per unit of time. It indicates the system's capacity to handle load. CPU utilization. This measures the percentage of CPU resources consumed by the system. High CPU utilization may indicate a CPU bottleneck. Memory utilization. This measures the amount of memory consumed by the system. Memory leaks can lead to high memory utilization. Disk I/O. This measures the rate at which data is read from or written to the disk. High disk I/O may indicate a disk bottleneck. Network bandwidth. This measures the amount of data that can be transferred over the network in a given time. Network bottlenecks can result in reduced network bandwidth. By monitoring these metrics, testers can ensure that the system meets the expected performance standards and delivers an optimal user experience. 22. How does LoadRunner handle dynamic data in scripts? LoadRunner handles dynamic data in scripts through a process called correlation. This is a method of capturing and storing the dynamic data from server response. When a script runs, it replaces the dynamic data with this stored data. The primary purpose of correlation in LoadRunner is to handle server-dependent, unique and dynamic values which the server generates during script execution. This ensures that every time a script runs, it uses the correct, up-to-date data, thereby improving the accuracy of testing. LoadRunner provides both automatic and manual methods for correlation. The choice of method depends on the complexity of data and script, and the tester's preference. Correlation helps in managing session-related information, handling server-generated, unique and dynamic values. Without correlation, the scripts will fail during execution as they will not be able to handle dynamic data. It is one of the most important concepts in performance testing. Using LoadRunner and mastering it is essential for any performance tester. 23. Discuss the difference between load testing and stress testing using LoadRunner. Load testing and stress testing are two different types of performance testing that can be conducted using LoadRunner. Load testing is a type of performance testing where the system is tested under the expected load. This type of testing is done to determine how the system behaves when multiple users access it simultaneously. On the other hand, stress testing is a type of performance testing where the system is tested beyond its expected load. This helps to identify the breaking point of the system and determine how the system recovers once the load is reduced. Both these tests are crucial in ensuring the robustness and reliability of the system. Load testing using LoadRunner involves simulating a situation where multiple users access the system at once. It's a way of determining how the system behaves under expected load. If the system can handle this without experiencing issues, it's considered to have passed the load test. On contrast, stress testing pushes the system beyond its expected load. This testing is conducted to find the breaking point of the system and understanding how the system recovers post-peak load. It's a way to gauge the robustness and reliability of the system. Both these tests are integral in ensuring a smooth user experience. These tests conducted using LoadRunner help in identifying potential issues and fixing them before they impact the end users. 24. What troubleshooting steps would you take if a test fails to execute correctly? If a test fails to execute correctly, my initial step would be to check the error message or log files for any specific details about the error. This can often provide valuable insights into why the test failed. If the error message is unclear, I would rerun the test with debug settings enabled to gain additional information. Next, I would ensure that all test prerequisites are met, including correct configuration settings, required data inputs, and system requirements. I would also check whether the software or system under test is functioning as expected outside of the testing context. If the problem persists, I would try to isolate the issue by executing smaller parts of the test independently. This can help pinpoint the exact area where the test is failing. In some cases, it might be necessary to consult with other team members or with the tool's support team. They might have encountered similar issues before and can provide necessary guidance. Lastly, I would ensure that the test is designed and scripted correctly. Any issues in test design or scripting can lead to test failures. Remember, effective troubleshooting requires a systematic approach to identify, understand, and resolve the issue. 25. How can you integrate LoadRunner with other tools or platforms for enhanced testing capabilities? LoadRunner can be seamlessly integrated with various tools for improved testing capabilities. For instance, LoadRunner can work hand in hand with HP Diagnostic for identifying performance bottlenecks. It can also be linked with HP Application Lifecycle Management, to manage all aspects of software lifecycle from a central repository. Integration with IDE like Eclipse or Visual Studio allows for the development, editing, and debugging of scripts directly. LoadRunner can also collaborate with SiteScope for real-time monitoring of servers during load testing. LoadRunner's integration with other tools not only streamlines the process but also extends its functionality, making it a versatile solution for performance testing needs. This compatibility with various platforms and tools makes LoadRunner an invaluable tool in any testing environment. We trust that this comprehensive list of the top 25 LoadRunner interview questions and answers has been beneficial in your preparation for your upcoming interviews. It is our goal to equip you with the necessary knowledge to confidently answer any question related to LoadRunner. Do not hesitate to revisit this video as many times as you need to fully master each question and answer. Your support means a lot to us, so if you found this video helpful, please make sure to hit the like button. We also encourage you to subscribe to our channel for more insightful content. Best of luck with your interviews.